Okay, so in this video, I drew a pretty crazy graph. Um, so here's my graph. This is all one graph. Uh, there's a lot going on here, but this is intended to be, well, this is similar to some questions on the online homework. So we're going to use this graph to practice finding many different kinds of limits. So let's start filling these out. So the first one is the limit as x goes to -3 from the left. So this, maybe this is obvious, but this negative sign is telling me that it's -3. This is telling me that it's from the left. So here's -3, and I'm thinking about values that are to the left of -3, but close to it. So in this, we don't see too crazy of a situation. It looks like it's approaching this point. Even though this is an open dot, we know not to pay attention to that. So then I follow this over, and yeah, I'm not a perfect artist, but this is meant to be a y-coordinate of 3 here. Yeah. Similarly, if I go -3 from the right, now I'm looking at values of x that are close to -3 but to the right. If I go up here, it looks like it's close to the same point. It looks like it's just a 3. And by the way, so in these first two columns, we have a bunch of one-sided limits. It's always from the left or to the right. But in the third column, we have two-sided limits. So like, here's the limit as x goes to -3, and it's not specified from the left or from the right. And since we just did the left limit and the right limit separately, maybe I'll fill this one out now. Since these were the same and these were both 3, this one's 3. If these two things didn't agree, then I would say this one didn't exist, like last time. But these two were the same, so then this is the same. Okay, so let's move on. What about -2? And first we're going to do -2 from the left. So here we see something that we haven't seen before. So here's -2, and I'm looking at values that are slightly to the left. So if I start my pen here and I just trace the graph, what we see is something, and again, I'm not a perfect artist, and this isn't something that a human being can really draw, but we see it's oscillating faster and faster. Like it seems to be going up and down between like this level and this level, and it seems to be faster and faster to the point where when I was drawing this, I just ended up kind of scribbling right here. This is an example of a way that a limit can not exist. If it doesn't, I mean, there's a point right here, but if I'm approaching -2 from the left, I'm really just sort of like wildly going above that point and below that point, back and forth, faster and faster. I'm not getting close, like the y-coordinate isn't getting closer and closer to this point. The y-coordinate is wildly oscillating between this level and this level. So this is a picture where, at least the way I intended to draw it, this is a limit that does not exist. And actually, maybe I'm being a little bit picky here, but I wouldn't write equals dne, I would just write dne. So I just crossed off the equal sign there. Meanwhile, -2 from the right, there's nothing crazy going on. If I look at -2 from the right, it looks like it's approaching this point, which again is 3. Okay, so now that we've done -2 from the left and from the right, I will go over here and do the limit as x goes to -2 with no side specified, just the standard limit. This one, yeah, let me be careful. I was about to write equals, but I shouldn't write equals because the answer is does not exist because, well, this one didn't exist. In order for this to exist, these two things would both have to exist and they would both have to be the same. Unless these two are the same exact number like it was up here, this one doesn't exist. Okay, so moving on. What happens when x goes to -1? Whoops, yeah, maybe I'm going a little bit out of order. Let's do -1 from the left and then -1 from the right. I was doing the left first and then the right. There's nothing too crazy happening on -1. If we go from the left, it looks like it's approaching this point, so I'll say 4. If I'm going from the right, it looks like I'm approaching this point, so let's say 2. Since these two are not the same, this one does not exist. Okay, so then looks like I'm done with this column. Let me move over here. So now x is approaching +1 from the left. And over here on the graph, you might know these are called vertical asymptotes. So actually, if I try to approach 1 from the left, so I'll choose a value that's slightly to the left of 1, and I'll just sort of put my pen on the graph and start moving towards 1, I find myself going down and down and down, and it looks like I'm going down forever. This is something that we haven't seen before. This is an example. I would say this limit is -infinity. As I approach 1 from the left, the y coordinate is going to be like what we would call a huge negative number, which sounds a bit weird. How can a negative number be large? When I say a large negative number, I mean something like -1,000,000 or -1,000,000,000,000. The point is that this is going to go as far down in the graph as you would ever want to go, like by taking x very close to 1 and to the left, the y coordinate goes to -infinity. Meanwhile, if x is going to 1 from the right, and then I'm just sort of going to this point, so I would say this is 4. So now that I've done 1 from the left and 1 from the right, I can go down here. This is also does not exist, basically because these two didn't match. By the way, if these were both -infinity, then I would say this one was -infinity. So -infinity is a possible answer, but they didn't match. One was -infinity, the other one was 4. Okay, so moving on, let's do 2 from the left. So as I approach, so here's a value of x that's slightly to the left of 2, and I'll slowly move my pen to the right, and I find myself going up and up and up. So I'm going to write +infinity. This is just like -infinity, except instead of going down, we went up. So +infinity. Meanwhile, if I do 2 from the right, this time I see something similar. So I'll start my pen somewhere slightly to the right of 2, and then I'll move slowly towards 2, and I find myself moving up and up and up. So I would say this is infinity. And like I was saying, since the left limit was infinity and the right limit was infinity, this one I am going to say is infinity. Okay, so almost done here. Let's do 3 from the left and 3 from the right, and maybe I'll make this quick. 3 from the left looks like -infinity. 3 from the right looks like +infinity. We would say these do not agree. They're not the same, so this one I would say does not exist. Okay, so maybe that's, so that'll just be like a 10-minute video, because I need to prepare the next problems before I do another one.